So is it like locked on a distance?
Maybe that's.
Oh, I do like your
Or is it I think it's locked in your
Maybe
head?
that's why I think it's something butter.
Open
Is it butter
foot.
bread?
I've had that happen once.
Really?
Okay, it's actually kind of like it's
There was like that one day that people wanted a video.
Was
And it was
it?
like, it was just blurred. So what I did is I ended up going online and
Is it on right
I did the whole presentation on my iPad and I just submitted that.
Can we do the backyard again? Let's see your camera.
What?
You know, like the I'm Shaniqua and then
Shaniqua.
backyard friends. Tasha backyard. Is Tasha one of them?
No. All right, here we go.
Tasha probably wasn't. Shaniqua.
No.
Shaniqua.
It's Tyrone.
Tyrone and Shaniqua.
Tyrone, Shaniqua.
Pablo.
Simon.
Tasha.
All right. Hey. Hey. All right. First, we need to talk about a couple different problems today. There was one problem we didn't get to yesterday. It's about exponentials. We have to cover it. We also have to talk about linear functions and how they compare, and the data that's given to you so you know which one's which. And then the last thing I want to cover today is if they give you random data, can we come up with a function or a formula for it? So we're going to try a couple different examples today. My goal is to go through about 3, 4 different things today. If we get to the end of class and the bell goes off fine and dandy, we do have homework due tomorrow. That's your page 7 stuff. No matter what's going to happen, even if we get homework today or not, let's say we get homework tomorrow because that's just the time falls. I'm not really worried about it. No, it's due next Tuesday no matter what. And that's a short turnaround because we don't have class on Monday. So you have to take it home with you.
I have an essay due Tuesday, so it's not gonna work for me.
Yeah,
Okay.
so Labor Day means we don't have labor on.
I know, I wish it was the case, but it's not the case. All right, so here we go.
Make it
Let's talk about exponentials. I want to do a problem where it's something we haven't discussed yet. It's where you're trying to come up with a function, but all you have is a couple data points. So let's say that q is a function that's an exponential function. Okay, so q is an exponential function, and the data that they're giving me, or data, is they're giving me this. 25 is 91. Okay, so let's say that this is my exponential function. Now, it's not growing fast because there's different rates of growth for an exponential. It doesn't always have to be by 2s, so it could be by any other percent. But what most people don't know is how to take this initial set and come up with a function for it. I showed you shortcuts yesterday. Today is a different story because would you agree that these two numbers are not just one apart?
Yeah.
Okay, if they're more than one, because what I mean by one apart, I'm talking about from f of the number you plugged in to the next number you plugged in, I didn't just jump by a 1, I jumped by 5. That's going to affect what my final answer is going to be for this potential for this exponential function. Because an exponential function typically looks like this. I'll explain what all these terms are. This is basically what an exponential looks like.
Can't.
Okay?
There's no U.
I need to put a 0 on this. Alright, this is the generic form. I think what you guys are probably used to seeing is something like this.
A equals
I
per.
think we've done something like this before.
Yes.
Okay, something like that. What this stands for, and I'm going to use the top one because that's the way the book writes it. The Q is the amount that you're going towards. It's like the total in the end.
Is the T an exponent?
Yeah, that's in the exponent. So the T is like up here. It's up in the power.
It's a little T.
Yeah, sorry. The Q to the 0, it's called Q naught. That's how you pronounce it. Q naught is the initial amount you're starting with. So it's like the X you're plugging into the variable, the number you're plugging in originally. And then the A is the growth. We'll talk about that here in a second. I'm going to do a couple things on the board on that side that will explain it. Is it going up or down, that type of thing. And T is the time frame. These are the things you should be writing down so you kind of know it.
Are you sick, Ward?
Yeah, I got a cold. My allergies like
I
killed
thought
me.
you had
It
the
was
immune
so
system of a
stuffed up
horse.
yesterday.
It was bad.
Mr. Ward, I thought
Especially
you
in
had
the
the immune system of a horse. You never get sick.
But I'm allergic to something, and I don't know what it is.
Maybe
Peanuts.
Maybe
It's
your
peanuts.
apple orchard
It's your
spray.
fish.
It's your apple orchard
Your fish.
spray.
The apple orchard spray.
Yeah.
The fish.
That's right.
Wait, spray.
Quit using it and we'll stop.
Spray on your
No.
face to make sure.
No. That's right. Spray yourself. No. Alright. That can be the case. Alright. Now,
Wait, apple orchard spray?
this is stuff I spray like every
Can you
other
go smell
class.
that?
Can I go look at it?
What?
You can take your class, smell that.
I cannot stop.
Okay. Small sprays.
Wait, what?
Small sprays. Just keep it away from my fishbowl.
Why is this allergic too?
No, just it's kind of.
Would you, how mad
Mr. Ward,
would
you're
you
not
be
allergic
if I
to
put
that.
an M&M?
Yes, you are, Warren.
Straight or not? Straight up front.
Alright.
Well, that's probably it.
No, it's not.
You're allergic to your fish.
Or you're just getting sick?
Are you
Thought?
by chance allergic
Sydney, that's
to
No, hey.
Yes,
I'm not gonna.
shakes?
Humane
Okay.
society.
Alright. Hey,
Humane system.
let's walk through this. Now, here's the thing. On this part right here, the idea on this is that A is the actual growth. We don't know what the number is for the growth because it didn't jump by ones. It jumped a couple numbers down the road. So if it's jumping by more than just one, this is the trick that you have to do to set up your equation so it guarantees the right answer. If it went by one, you wouldn't have to worry about this. Like the example I did yesterday went by one. I didn't really show you the full potential what you have to check for. Okay, so here's how it works. The first one, I'm gonna use the 85. I'm plugging in the 20A,
Okay.
and here's the problem. I'm just gonna put a 20 up here in the T because I don't know what set that is. It's 20 years from the first one, like number one. So I'm gonna put an A20 up in the power. Okay? The next one, and this, like if you don't know the initial amount, you could actually call it like Q here. It's just all we're doing is we're trying to find the initial set of what my amount is. So the way the book does it, if you're looking at the book, they don't actually plug a number in for Q naught because we don't know what the initial amount was. So they leave this alone like this. Does that make sense? Because they don't know. They honestly don't know the initial amount. They just know how much you plugged it in now. This is 20 years down the road. Or 25 years down the road. They don't actually know what the initial amount was. So, the next one was 91? And we don't know what the initial amount was yet, but this was 25 years past the original. Because if it's exponential, everything's based on the original. Okay, now, to solve this, to actually figure out the amount that it's going by, here it is.
Here it is.
You divide the two from each other, and I always tell you, take the later one, because it's going up. So take the later one and divide by the closer one. So if you're kind of guessing what this graph looks like, it's looking like this. Like we're 20 down the road, it's going up obviously because it went from like 85 to 91. So I would take the later date. What?
Because that's the big
I'm going to divide, and what's going to happen is it will allow me to solve for A. I'll show you why.
Why are you doing that?
I'll show you. This is perfect. It makes one.
Have you ever tried peanut butter and bacon together?
You know the onion?
No, they're tomato. Sorry. Sydney.
Oh, it does look like tomato.
All right.
And then those are gonna almost hit the line.
Exactly.
So
Okay.
you have to bring the 25
So
to
now,
20 to the front.
We're starting to see what's going on here. Okay. If we divide the 91 by 85, the question is why do we divide? It will help us solve for A, the amount that it's growing by. Because if you're actually looking at the math here, these two equations are supposed to represent the same exponential form. If you divide them, you can see what the growth was because exponentials are just multiplying by a certain number. So if I divide 81 by 85, let me divide this. 91 by 85, I get a 1.07. Now, there's more numbers, but
How do we pick which one's on top?
Is that a sales tax?
I always pick the later date one. So like if it's 20 and 25, I pick the 25 one. not just what number is bigger, because it could be decaying, it could be growing smaller in number, but I always pick the later date, so if there's a F of 20 and an F of 25, I pick the
Would it
25.
make a difference if you did the other way around?
Yeah, it would. That would show decay. It'd be the same number, it'd just be decay, it'd be negative. So now, if we divide these, the Q0, this is the initial amount you started with, those cancel out, because when you divide them, they make 1. And what we're left with here is a to the 5, because if you go through normal algebra 2, the laws of exponents, the a to the 25, a to the 20, they'll simplify to be a to the 5, and then to solve for the rate, you have to take the 5 to the other side and take a 5th root.
I don't understand.
For the
You
1/5 power.
just take a 5th root so that it equals A.
I don't know if they're right.
Yep, you take a 5th root to the other side, because you need to get what the original a was, not a to the 5th.
Right.
And what this will give you, it will give you a number that's smaller than, obviously smaller than 1.071, but it should be over the number 1 still. It'll be 1 point something still. Now, how you type that in a calculator is something we haven't seen since, I guess, algebra 2 days plus you, or I guess pre-cal. We talked about pre-cal.
1.01381308.
How you type that in?
Okay.
Root, of the 5th root of 1.071. You type in 1.071.
Shut up.
You hit the little caret key, you hit the caret key, you put a parenthesis, and instead of doing the radical, you can write it as a fraction 1/5.
Or
1/5 is a 5th root. Fractions represent radicals, and the bottom number would be what root it is. So 5th root, the 5 goes in the bottom. This gives you, what was the number again?
1.0138.
0138, perfect. So it's actually growing by about 1%, 1.3%, because the actual percentage is back here. It's going 100% and a little bit more. So it's actually growing by this percentage.
Is that a good percentage of growth?
It's decent. I mean, especially in, exponentials, it's pretty big.
Yeah,
Like
if you
usually
want-
exponentials are really, really small numbers. Like 0.5%, 6%. I mean, 0.5% is what savings accounts go at. 0.5%.
Except for a 0.5% is not.
It's hardly anything. That's why your savings account doesn't really grow fast, unless you have a really big amount of money in there.
What if you had $18 million in savings?
Yeah, that'd be big.
How
You'd
long
have,
would
you'd
you
have a
use
lot.
it? $20 million.
So
Yeah.
why don't you take out a bank loan of $18 million, put it in a savings account, have it grow, then pay it back?
Offshore
You
account.
can't do this.
Why not? They won't know, just
Keep
go
all
to a
your
different
money in
bank.
Switzerland, Swiss bank.
Take
You
a loan
couldn't be
out.
approved for that.
Is that what we're lying?
What?
Is that what
Okay.
people do?
Swiss banks are cool.
There was a couple tech entrepreneurs that tried to
They
do
don't
something very similar to that.
Did they win?
No, I think they got sued for fraud.
Wait,
So,
Who?
who got sued for fraud?
there's a bunch of tech
entrepreneurs.
investors where a bunch of people had a bunch of money and they tried to borrow a bunch of money out of banks and put it in a savings account and try to build interest on it. It was a pretty clever scheme because they make a lot of interest and they had a lot of money sitting in that bank. And they got
Why
charged
could they
for
get
fraud.
sued for that? They're just
Why?
being smart.
Yeah.
Yeah.
They game the system. I
What's
think.
illegal about it?
So they're defrauding because you're not supposed to take a loan with other people. That was the fraud they
Okay,
had.
so if you did it by yourself, it'd be okay?
Yeah, it would have been fine if you can get approved for that loan.
Why don't you do
I
it?
I
can't.
don't have that type of money. They wouldn't even approve me for anything.
Well, they wouldn't approve you because if you don't pay, then they're just out everything.
Yeah.
What's your house for collateral?
Now, all right. Now, hey, does everyone see the difference between this problem and the last problem? Yesterday's problem, I didn't have to do this whole 1/5 idea, the whole radical, because my numbers were one space apart. So if my numbers were one space apart, you would only have a 1 sitting here. So
And then
you
we
did.
just leave
Yeah,
it.
you wouldn't need to take the radical of like a 1, because we don't have a first power. We have we have a square root which has a root of 2. So the idea is that when they're spaced apart like 20 to 25, this is the route we have to go. I just didn't talk about it yesterday because I didn't even think about it until I was kind of looking at some homework problems. And there's problems that they're spaced more than 1 away, and they are asking for a rough guesstimate of the growth, which is by 1.3%. What the generic formula would have been, which would have been this with their 1.138 in here. But the initial amount we don't have yet. But like that, they're asking for formulas. Now, does everyone understand that stuff? Or at least
Yes.
not perfectly understand, but are a little more comfortable with it now.
Yeah.
We're grasping.
Okay.
You know what you should do?
Yeah.
You should make a Twitter account and send out reminders on it and be like, hey everyone, homework assignment's due tomorrow.
That actually would be a really good idea.
1/2x plus
For
2.
the fish?
Yeah.
You
So this
tweet
will
out
work.
reminders.
We tweet out
For
videos
five
we do every
We
day.
don't know. For 5 is
Because it's attached to the website, so it just automatically tweets it out, so I just
Oh,
never
wow.
figure it out. Because I don't,
Yeah, it
you
says
just be
right there.
spammed by 4
Zero,
videos
zero.
every single day.
Oh, it's 5.
It's just, there's nothing else in the
Look
post
at
anything
4
else to it,
different.
so.
Can you please actually do that, make a Twitter account for this class, and then you can post the assignments on there?
I do that.
One second.
On what?
No, but it's Twitter.
It's
You
two.
don't have
It
Twitter
says-
account.
Yeah, it's
Yeah,
Twitter,
it's
it's
the 0,
just
2.
shark bait. That's what I, that's what I use. to-
Shark bait. Wow.
What's his bio?
No,
Twitter
man.
bio?
He's a fish, he lives in room 19. That's how
Wait, Mr. Warren, can you like do one for geometry,
Is this room
one for
19
calc,
still?
one for pre
Oh, you want individual, I just have it in one and the videos post every single day. So, and if you click, it takes you right
How
But
many
if I turn on
followers does it
notifications,
have?
I'll get like 70 notifications a day, and I don't want to do
4,
that.
only 4 a day.
4.
Well, those are the videos, not the actual,
Notifications
not the
on one
actual
account,
assignment.
that's not how-
Yeah, the assignment's on those videos.
I don't know
Yeah,
if
but
four,
if you like post
4
just the
days
assignments.
enough
Oh,
though. Yeah,
I can do that. Alright, I can do that because it's an easy thing, I can type it in. Alright, now, the next thing I want to talk about is the difference between exponentials and linear equations. I want you to see a story problem, not a story problem I should say, but just a problem where what they give you is, it would make a difference whether it's exponential or if it's linear. So, I'm gonna give you 2 examples. I'm just gonna pull a problem from the book, I just wanna get the same wording that they use.
Okay.
They say something like, okay, population, so I'm gonna use the population of Garner.
Do you want me to hold the book?
No, it's fine.
Okay.
So population,
have you not.
population of Garner, Iowa.
18 million.
No, Garner,
It's
Iowa
like 3,000.
in 2016 was
Yeah.
3,075.
Times 10.
Is that the actual population?
I did the research this
Yes.
morning.
Oh, okay.
Okay, of course he did.
We're up to like
So why did you look at the book?
Can you
if
So I'm looking at what the problem, the wording
Oh,
was.
okay.
Okay, so in Garner, it was 3,075 back in 2016.
That was a long
Okay.
time ago.
The question says, find the formula that represents the following data.
Yeah, but it's not.
Data.
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 Okay,
Data.
so
Data.
letter A, part A of this question. So you were finding the formula. The population increases by, population increases
25.
by 25 people per year. So that's part A, 25 people per year. Okay, they want a formula. Well, just knowing the difference between that and the next one I'm going to show you, which is part B, will tell you if it's linear or exponential. Part B, the population growth. Population grows by 1.025%.
That's a square root actually.
So if these are my 2 options, and I'm supposed to come up with a formula that represents this, the top one, this one, the top one, letter A,
Linear.
that's linear. The reason why,
Linear.
this one's linear. It's going by the same number every year. It's not changing. 25 people, 25 people, 25 people. That's linear. If you looked at a chart, you'd see, okay, it's jumping by 25s every time. That's linear. That's in order. The formula for it is this. It's your initial amount you started with, plus the, I guess the 25 people
To T.
to T. Because every year, every time, it's 25 people adding on. That's linear. That's a linear equation. It's y equals mx plus b. Whoa.
And then
So
the
this
other
would be
one-
your function. Now, the other function, if I'm growing by 1.025%,
It's gonna be
It's gonna be,
3,000
you know, the population, my initial amount, which is, I guess, 3,075,
equals Q.
times my rate, which is 1.01025 to the T. Now, here's the reason why. It's 100% growth plus the 1%. So it's all 100% of your 3,000 people plus the 1%, I guess 1.025%. That's this number. Because if I were to move that decimal, if I were to get rid of this, that'd be your 1.025. 100% plus the 1%.
No.
That formula, I guess I'll put it as g of x, is the exponential. Now, I know that you're probably thinking, okay, we've done exponentials differently in the past. We have. We've had growth, we've had decay. There is a way to do growth and decay other than just using this 100% idea. This is using that I think we called it simple interest. That's what we called it. And it's just taking the percent plus 100. Well, what we're doing is we're not going exponential like by e, we're going by our own numbers. E is that 2 point some number, 2.4 or something like that. Okay, I want you to take a look at those two problems. We're going to restart camera here and then we'll get going on to the last problem today.
Anything? No, anything.
All right.
Mr. Ward, I have a question.
Real or it's either
Question.
real or imaginary.
What is the definition of a real number?
Anything that's not a negative square root.
Real numbers are anything positive, negative, decimals.
Doesn't have I.
It's all the classifications of numbers combined using the completeness property. I don't know the exact word.
I don't know what the completeness property is.
Everything that doesn't have I.
Okay, never
So it'd
mind.
be for bigger.
No, I think in that problem, they're asking for like full numbers. Because it's, no.
It's anything
They're
that doesn't
asking.
have I.
Integers, whole numbers, rational, irrational.
Greater- so
So irrational numbers count.
You have to
Yeah,
use,
irrational.
for that pay, for
Not
that.
imaginary.
I got it.
Everything that's
You
not
have to use a
imaginary.
union for that problem.
No, you don't.
Yes, you
You just said
do.
anything that's not imaginary.
All right.
What did he just say?
Anything that's not imaginary.
No, for that problem, it's gonna be -1,000 to -4,
Oh,
and
is
then
he coming up
union.
with sets? Is that what he's doing?
I don't know what he's doing.
No,
Why
it's just
negative
like
1,000?
Because it can go to -1,000 and then it's
All right.
the square root or something.
Last question of the day.
Are you on?
Last question. This is a question I saw in the book. I was looking through the homework, and I liked it because it talked about exponentials. It was something that I didn't really think about until you just put it through the common sense. Okay, so yeah, this is gonna be my terrible artistic talent here. Okay,
Is it a
all right.
how?
This is your copy machine.
It's copy.
Okay, there's my copy machine. Okay, it's terrible. Every time you feed a piece of paper into it, so you feed a piece of paper in, the paper coming out is 80% its original size.
Sample 2 and 3.
This is a weird copy.
Yeah, it's stuck on this weird setting with whatever you throw into it. It's not giving you a perfect one-to-one like a normal copy machine would do. It's reducing the size of the picture by 80%. So it's shrinking everything down, even though it's printing on that paper. So everything's coming smaller. So here's the question. At what point, how many copies could you put through? Okay, like, so the same piece of paper, you ran it through once, you run it through again. How many times could you do that until it's 15% of its original size or less? So, how many copies would you need to make?
But you can use negative.
How many copies
Yeah, negative square root is.
Until.
until
Four. Yeah, but you have to square it. If
the
you plug in a negative.
the image
then it's
Okay,
60.
so it's greater or equal
So
to
is
4.
less than
Less than. or
20% reduction.
Forget.
or equal
I'll bring
80%. So it's gonna be 80% of its size.
So it's a 20% reduction.
0 times
Yes,
0.
basically a 20% reduction. It's 80% its original size.
So,
It's
so
But then
equal.
can you go all the way to negative?
Less than or equal to 15%.
yeah,
Sitting.
because the square root will still be bigger than
6
16.
copies.
As long as it's bigger than 16.
Right, so then it's 4.
So it'd be-
It's 3 whole.
Negative.
So yeah, so you're kind of right.
So it'd be
Right,
like
20%
4.
reduction.
Negative.
Okay.
4 bracket. Union.
Okay, so the copy coming out will be 80% the first time. I want to know how many copies will you need to make until it's below 15. You could do it by hand. You could just, draw a couple things, write a couple numbers down, do some calculations. I want to know how many would it take to get down to 15. Till you're below 15% in original size. Because the first copy coming out is 80%. The next one coming out is 80% of that one.
Oh, it'd be like,
So it's shrinking quick. But how many copies until it will be below 15?
like that.
Let's figure it out. I want to see it.
So it's less.
So let's talk about how. Do you agree that it's exponential?
Yeah.
That if I keep feeding that paper through, it's getting smaller and smaller quickly.
Yeah, square root.
Okay,
Yeah.
so let's talk about if it's truly exponential. It's not just saying, oh, it's taking off, 4 inches every time. That would be linear. You could figure it out. It's taking 80%. That percent right there is kind of telling you that it's going to be exponential. So here's the idea. This is how I do it. It's an 80% reduction. So that's my percent. It's not growing, it's shrinking, so 80%.
I feel like this is more.
The original paper was 100, right?
100.
It's 100%. I'm just gonna put it as 100. The paper, what I want to have happen, I want to figure out when this thing will be 15 in size.
And then it'll be 0.15.
I'm just gonna say 15. The paper was 100, let's say 100 feet. I want to know when it's 15.
Oh, because you did 100.
Yeah.
Find the 2 coordinates. And
Does that make sense? What I'm doing? Okay, to solve this, this is truly an exponential problem. The t is how many times you're gonna have to copy. It's not just a year, now it represents copies. So, to do this, you divide the 100 over, because I need to get that exponential by itself. So that's going to be 0.15, 0.80 with a t on it. We're going to take the logarithm of both sides, not a natural log, we'll just do a normal log because we don't have an e on this problem. So we're going to do a log, 0.15. We're going to take a log of this side, and Dross, you were even saying, what were you saying a little bit ago?
Drop the t to the front.
Drop the t to the front, because anytime you take a log, the power can drop out front. That's a power rule.
And then you divide log 0.8 over
Boom.
both sides.
If you divide this over, that'll be your t.
Heck yeah.
I'll do it for you.
Okay, so t is going to be log of 0.15 divided by log 0.8.
T equals 8.5.
Okay, so it's saying that you got to go 8.5 copies. So you can't have 0.5 as a copy.
No,
So-
you can do half a copy.
No.
Did you get it?
That would just be silly. Just hit cancel. It's
Yeah.
like,
Just pull it
All
out.
right. So 9 copies.
Yeah,
So
it's on-
Mark, your original guess, 10 copies. Pretty close. Pretty close. 9 copies before it's 15%. Okay. Now
I literally don't understand what this means at all.
I don't
Blue
even.
eyes.
it's showing like
so much theoretical.
Yeah, blue eyes.
It's a
it's
conspiracy.
the idea.
Why would it go through a copy machine and the image goes down?
Sometimes there's a setting on there. You can actually change sizes of pictures.
Okay, but wait, if it's,
Now that's not the practical problem.
It's
Here's what I'm trying to say.
5.1808.
Okay, why you never do something like that? You're trying to make a copy to a smaller size. Now computers you just resize, right?
Oh yeah.
This is something you have to do if you want to make a big picture smaller. Back, years ago when we didn't have Photoshop, we didn't have very easy graphical settings. You had to run it through a copy machine, put it through. If you had to reduce it, you had to figure out how many times you had to take that piece of paper through to reduce it, to see to get it down to the right size so you can put it on your chart or whatever you needed. Okay, now the one thing I have done is that I had a picture, but I wanted to blow it up. And I wanted to make sure it was bigger. Okay?
Oh, that's a
And
growth.
so it's a growth problem. Well, here's the problem. I'm not gonna just make it easy like, hey, I wanna grow by, 20%. Well, duh. Just put 20%, 120%, and boom. It's 120% growth. What I wanna figure out is this, that if I accidentally, so I had a copy, and I ran it through the copy machine, and it was somebody else's, so I gave their copy back to them. So here's my copy machine. Okay?
I'm telling a lie.
That looks like a really good copy machine, actually.
Okay, so I took somebody's copy of something, ran it through the copy machine, it came out by accident, I didn't even pay attention, it came out reduced 80%. Reduced. Okay, I didn't notice. I ran it through the copy machine, I didn't realize that setting was still turned
How am I
on.
supposed to do that?
And I had the copy, I gave them the original, they walked away. I picked up my copy and went, oh my gosh, it's too small. It just reduced my copy.
Oh no.
So what I need to know is what do I need to do to this machine? What setting do I need to hit that I can run this copy back through the machine
To get it to
to
120.
get it back to 100.
Oh, 100.
I want to go back to the original. So now I'm enlarging it, but it's not the original size anymore. It's not just, oh, I'm going 120. It's not 120.
Oh
It's a
my
different
gosh.
number. So you got to run it back, and I want it coming out 100% original size.
So you want to get punched.
So it's at 20% now.
So here's how it works. This
So
is
then
the
it's
easiest.
500%.
Here's the easiest way to think of it. It's like this.
Just get punched.
It's 500. You forgot the O.
I missed her arm.
Okay. This is the original problem we did earlier. We had an 80% reduction. Okay, we ran it through a bunch of times and we figured it out.
So we put
The
0.2
idea
again.
here, the idea here is that I ran it through the machine once, one time. I ran it through the machine one time and it went 80%. I'm going to run it through one more time again, T of 1. So this has a 1 on it. To get it back to its original size, the initial amount, if I divide this over, it'll get back. So this Q is over here, right? I can figure out the paper size, I can figure out this, that's fine. But if I divide this over, it'll get me back to my original. So what's the number in front of Q?
0.8.
There's a 1 in front of Q.
Why?
Why?
Because every letter has a 1, every variable. So if I divide this over, that's 1 divided by 0.80 Q equals Q to the 0, the Q now.
How do we know what Q is?
Q is this is the paper that came out of the machine every time.
So it's
This is the initial.
1.2 then.
That's the equivalent to 1.25.
This,
Yeah.
if you type it in, is 1.25. That's the magical number we were looking for.
Oh yeah, I heard about it.
If you want to go backwards and grow, you have to think about how the problem originally worked and divide this number over, because dividing by this will change it back to the original. It's like when you multiply by 2 on a calculator by accident, you didn't even realize what you did. Like you had a number entered in your calculator and you multiplied by 2 and you're like, oh my gosh, I just messed up. Instead of clearing the calculator, divide by 2 and get rid of it. Yes. So it's one of those things like, you just need to see that concept that to go backwards on exponentials, it could be as easy as just dividing that number over and figuring out what that percent is. It's now 25% growth, not just 20, because going back doesn't perfectly scale. You're gonna have to go bigger than you think you would. Trust me, this is the number one thing. People that make copies, like on a major copy machine, don't understand how it works. Because they just think, oh, 20% growth, it'll get back to 100.
Are you
20
saying
plus
that
8.
we need to know calculus to be able to make copies?
Yeah.
Yeah, I feel like I'm gonna print stuff next period. I'm probably gonna do this
What if I
math
just
class
change the
before I
setting so it's not 80% reduced, it's at normal?
I agree. Agreed.
But what
Make it
if the
100.
copy machine
But
breaks?
if you ever had something that was too small and you need to get back to the original size, you now know how to do it.
No,
I still don't.
Well, you should have paid attention.
I paid attention because that's
All right.
actually supposed to say.
Today, you're not getting any homework today. You have 5 minutes left of class, 6 minutes technically. Make sure that you are trying to finish up this page 7. It is due tomorrow.
Every minute counts.
Look at this. Book check for any that was gone yesterday. Was anyone gone yesterday?
Hey, do you have another paper bag? More from the bathroom.
I ran out again.
Laura, do you have your
Wait till Jake.
notes in there? Did you make all of them?
I'll get it.
Right now, joust.
Not working.
Are we in your favorite calc class?
What?
Are we in your favorite calc class?
Yes.
Remember when I checked
Are we your least favorite?
Did you do this with the other calc class today?
No,
Or not?
because I don't have one.
Yes, you do.